The F-22 Raptor is already one of the most advanced fighter jets ever built, but what the U.S. Air Force is doing to it right now, in classified hangars with billions of dollars and some of the most brilliant aerospace engineers on the planet, goes beyond anything the public has been fully briefed on. We are talking about a transformation so radical that insiders have started calling the upgraded aircraft the Super Raptor. An aircraft that was already ahead of its time is being rebuilt from the inside out to stay dominant well into the 2040s. Tonight, we are going to go deep inside that program. The real engineering, the real history, and the real stakes. Leave your like, subscribe, and share. Let's begin. To understand why this upgrade matters, you have to understand what the F-22 already is. The F-22A Raptor entered service with the U.S. Air Force in December 2005 after one of the most expensive and technically ambitious fighter development programs in history. Its official unit cost is approximately $150 million, but with development costs factored in, that number climbs toward $350 million per aircraft. Only 187 operational aircraft were built, a number far below the original plan of 750. Because Congress cut the program after the Cold War threat environment shifted and costs spiraled. That decision is now widely regarded as one of the most consequential errors in modern American air power planning. What made the F-22 special in 2005 still makes it special today. The aircraft combines low observable stealth technology with supercruise capability, meaning it can fly faster than the speed of sound without using its afterburners. Its top speed is classified, but open-source estimates place it above Mach 2, and supercruise speed around Mach 1.8. It carries an AESA radar, active electronically scanned array, which gives it the ability to track dozens of targets simultaneously while also functioning as an electronic warfare tool. And it has a thrust vectoring system in its engines, the Pratt & Whitney Phone 119, that gives it maneuverability at low speeds that borders on the physically absurd. In close-range combat simulations, the F-22 has a kill ratio against fourth-generation fighters that runs as high as 100-to-1. But here is the problem. The F-22 was designed in the 1980s and 1990s. Its avionics, the computer systems that run the aircraft, were cutting-edge then. Today, by the standards of modern computing and signal processing, they are antiques. The processors running inside an operational F-22 right now are generations behind what is in a modern smartphone. The data link system, the way the F-22 communicates with other aircraft and ground stations, uses a system called Intraflick, which is proprietary and not compatible with the standard Link 16 data link used by every other U.S. and NATO aircraft. That is not a minor issue. In a modern air battle, the ability to share targeting data in real time across all platforms is not a luxury. It is the central operating principle. An F-22 that cannot talk to an F-35 or an E-7 Wedgetail is an F-22 that is fighting blind in a networked war. This is the core of what the Increment 3.2B and subsequent modernization programs are addressing. The U.S. Air Force has committed to a multi-phase upgrade roadmap that includes new avionics processors with exponentially greater computational power, a new radar warning receiver to detect modern surface-to-air missile systems, updated electronic warfare suites, and most critically, a new data link architecture that allows the F-22 to communicate and share data with the broader Joint All-Domain Command and Control Network, known as JATM. This is not cosmetic. This is rebuilding the nervous system of the aircraft. The radar upgrade is where things get truly impressive. The current APG-77 AESA radar on the F-22 was a revolutionary system when it was designed, but the hardware and software running it are now decades old. The upgraded variant, referred to in unclassified documents as the APG-77 Bone, uses modern gallium nitride transmit-receive modules. Gallium nitride, or GaN, is a semiconductor material that allows radar systems to operate at higher power levels while generating less heat, which directly translates into longer detection range and better performance in electronically contested environments. The practical effect is that the upgraded F-22 will be able to detect and track targets at ranges significantly beyond what the current radar can achieve, and it will do so against adversaries who are actively trying to jam and deceive it. The electronic warfare upgrades are equally significant. Modern Russian and Chinese air defense systems, including the S-400 and the HQ-9B, operate across a wide range of frequencies and use sophisticated signal processing to detect stealth aircraft. When the F-22 was designed, these threats did not exist in their current form. The aircraft's radar cross-section, its stealth signature, remains one of the lowest of any operational aircraft, reportedly equivalent to the radar return from a steel marble. But stealth is not invisibility, and as adversary radar technology has advanced, maintaining that edge requires constant investment in both the airframe's physical coatings and the electronic systems that suppress and deceive detection. The upgraded electronic warfare suite being integrated into the Super Raptor package includes new jamming capabilities and infrared countermeasures that address the current generation of threat systems. Then there is the weapons question. The F-22 carries its weapons internally, a critical feature of its stealth design since external pylons would dramatically increase radar cross-section. Its primary air-to-air loadout consists of 6 AIM-120D advanced medium-range air-to-air missiles, known as AMRAAM, and 2 AIM-9X Sidewinder short-range missiles. The AIM-120D has a range of over 100 miles and represents one of the most capable radar-guided missiles in the world. But the threat environment is evolving. China has deployed the PL-15 missile, which is estimated to have a range of over 200 miles. Russia fields the R-37M, which can engage targets at extreme ranges. Against these weapons, the F-22 needs not just better sensors, but expanded weapons options. The answer is the AIM-260 Joint Advanced Tactical Missile, or JATM. The JATM program is one of the most closely held weapons development efforts in the U.S. inventory. But what has been confirmed is that it is designed to outrange and outperform the PL-15. It uses active radar homing with a two-way data link, allowing pilots to update targeting information mid-flight and potentially redirect the missile after launch. Integration of JATM with the F-22 is a central element of the modernization effort, and it transforms the aircraft's beyond visual range combat capability in a fundamental way. Where the current F-22 might find itself in a missile range disadvantage against the most modern Chinese fighters, the upgraded aircraft with JATM closes that gap decisively. The engine story is also critical. The F-119 engines that power the F-22 are extraordinary machines. They produce approximately 35,000 pounds of thrust each with afterburner, and their thrust-vectoring nozzles allow the aircraft to point its nose in directions that defy normal aerodynamics. But those engines are now approaching 3 decades old in design terms. Pratt & Whitney and the Air Force have been exploring adaptive cycle engine technology that could eventually replace or substantially upgrade the F-119. An adaptive cycle engine can switch between high-thrust and high-efficiency modes in flight, giving the aircraft both the power needed for combat and the fuel efficiency needed for long missions, a combination that fixed-cycle engines cannot achieve. While the full adaptive engine replacement is more likely to appear first on the F-35 and the next-generation aircraft, incremental improvements to the F-119's performance and sustainment are part of the Super Raptor upgrade package. Leave your like, subscribe, and share. There is also the question of the aircraft's airframe itself. Composite materials, which make up a significant portion of the F-22's structure, degrade over time and require careful management. The aircraft's radar-absorbent materials, the coatings that give it its stealth properties, are notoriously maintenance-intensive. Each F-22 requires thousands of labor hours per year just to maintain its low observable properties. One of the less glamorous but critically important aspects of the modernization program involves improving the durability and maintainability of these coatings and materials, reducing the maintenance burden so that more aircraft can be available at any given time. An F-22 that is in the hangar being recoated is an F-22 that is not available to fight. The geopolitical context driving all of this is the rapidly evolving Chinese Air Force. The People's Liberation Army Air Force has fielded the J-20 stealth fighter, which represents a genuine fifth-generation capability. It is powered by Russian AL-31 engines in early variants, with Chinese WS-10 engines replacing them in production aircraft, and a more capable WS-15 engine expected in later versions. The J-20 carries 4 long-range missiles in its main weapons bay and 2 short-range missiles in side bays, and it is being produced in significant numbers. Beyond the J-20, China is now testing 2 sixth-generation aircraft, the J-36 and what analysts call the JXX, that represent the next leap in Chinese air power. The United States cannot allow its premier air superiority fighter to become obsolete while it waits for its own sixth-generation aircraft to mature. That sixth-generation aircraft, designated the F-47, was publicly acknowledged by President Trump in March 2025, when he confirmed that Boeing had won the next-generation air dominance contract. The F-47 represents a leap beyond even the Super Raptor, but the F-47 is years away from operational service. In the meantime, the upgraded F-22 must serve as the cornerstone of American air superiority. The investments being made in the Super Raptor program are not about nostalgia for a great aircraft. They are about maintaining combat power in the most contested airspace in the world during a period when adversary capabilities are advancing faster than at any point since the Cold War. One of the most technically fascinating aspects of the upgrade involves the aircraft's sensor fusion architecture. Modern air combat is not just about having better individual sensors. It is about how rapidly and accurately a pilot can process information from multiple sensors simultaneously and make decisions faster than the adversary. The F-22's current mission systems computer processes radar data, infrared search and track data, electronic warfare emissions data, and data link information through an architecture that was designed before multi-core processors existed. The upgrade replaces this with a new open systems architecture built on commercial off-the-shelf computing standards that has processing power orders of magnitude greater than the legacy system. This means faster track file updates, better identification of friend from foe, and a pilot workload that is dramatically reduced even as the information available to them increases. The human factors aspect of this cannot be overstated. An F-22 pilot today manages an extraordinarily complex information environment in an aircraft that was not designed with modern human-machine interface principles. The cockpit has been upgraded incrementally over the years, but the fundamental architecture remains that of a 1990s aircraft. The Super Raptor modifications include a new large-area display system, a color multifunction display suite, and helmet-mounted display integration that allows pilots to cue weapons and sensors simply by looking at a target. These improvements directly translate into faster reaction times and better situational awareness. And in air combat, fractions of a second are the difference between survival and destruction. The cost of all this is significant. The full F-22 modernization program is estimated to run into the billions of dollars across the entire fleet. With only 187 operational aircraft, the per-aircraft cost of modernization is substantial. Critics have argued that this money would be better spent accelerating the F-47 program. Supporters counter that there is no alternative. The F-47 will not be operational in sufficient numbers for years. And in the meantime, the United States needs the most capable possible air superiority force. Both arguments have merit. What is not debatable is that the F-22, even in its current form, remains the most capable operational air superiority fighter in the world. And with the Super Raptor upgrades, it will remain so for a generation. The physics of what this aircraft does continue to astonish even the engineers who designed it. The combination of supercruise, thrust vectoring, low observable signatures, and advanced avionics creates a warfighting tool that no adversary has yet matched in a single airframe. The J-20 is a genuine peer competitor in some respects, but independent analysis consistently concludes that the F-22 maintains significant advantages in stealth, maneuverability, and sensor performance. The Super Raptor upgrade widens some of those advantages and closes the few areas where they had begun to narrow. What we are witnessing is something remarkable in the history of military aviation, a program that takes an already legendary aircraft and systematically transforms it to face threats its designers never imagined. The engineers working on the Super Raptor upgrades are not just maintaining an aircraft, They are redefining what a fifth-generation fighter can be, and they are doing it fast enough to matter in the strategic competition that is already underway. Leave your like, subscribe, and share. Until next time.